Welcome back to another video here on the Unknown Coder YouTube channel. Today we are looking at the LeetCode problem 747, largest number at least twice of others. This problem states you're given an array called nums that has integers in it where the largest integer is unique. So this part is pretty important. There is going to be a largest integer and it's always going to be unique. The goal here is to determine whether the largest element in the array is at least twice as much as any other number in the array. If that is true, we'll go ahead and return the index of the largest element. Otherwise, we'll return -1. So basically, we're going to make sure that the largest element, whichever one we find, is double the size. Let's go ahead and take a look at the examples they give us. So for example number 1, they're going to give us an input array called nums, and it's going to have 3, 6, 1, and 0. So here, the largest value is going to be 6. So then what we need to do is see if 6 is double the size of all the other ones. So 3 times 2 is equal to 6, so that one counts. We're going to skip 6. 1 times 2 is equal to 2, which is still less than double 6. And then finally, 0 times 2 is obviously 0. So 6 is greater than all of those, or equal to, so we'll go ahead and return the index 1. And that's what we return. Now let's go ahead and take a look at the second example. In the second example, we're going to be given an array called nums again, and it's going to have 1, 2, 3, 4. So obviously here, the largest number is 4, but if we say 1 times 2, that's technically double 4, but 2 times 2 is also technically double 4, but 3 times 2 is equal to 6. This is not at least double 4, so this won't actually work. So then we want to return the index of -1, and that will be the end of that. So let's go ahead and pop back up and take a look at our constraints. So for this one, our constraints are pretty simple. The first one saying 2 is less than nums.length is less than or equal to 50. So what this is saying is that nums.length will have at least 2 elements, and at most 50. So we're always going to have at least an element to check against. Moving on to the next one. The next one states 0 is less than nums of I is less than or equal to 100. This is again very simple. All this is saying is that the values inside of nums are between 0 and 100. So nothing crazy or fancy there. This is all good. The final one states that the largest element in nums is unique. This was important because it's basically going to tell us that we don't need to worry about looking for some duplicate largest value. Once we find the largest value, we're good to go. So again, the goal here is to loop through keeping track of the largest element inside the array and also keep track of each element to make sure that they are 2 times as large as the rest of the elements. Now this problem is actually very simple to solve. We just need to break into 2 separate parts. The first part is finding the largest value inside of the array, which is not very hard to do. And then the second part is to check every value other than the index of the largest element to see if the largest index is twice as large as all the others. Let's go ahead and take a look at the pseudocode and example walkthrough for hopping into LeetCode. So to start out with our pseudocode, we're going to go ahead and say let max value be 0. And then what we want to do is say for each element in nums, if the value is greater than max, go ahead and set max to that value and set the index. That would complete our first step. Then the second step, we want to say for each value in nums again. Then we want to say ignoring the index of max, we want to go ahead and say if max is greater than the value times 2, continue. Otherwise, return -1. And then if we make it all the way through the loop, we'll go ahead and return index. So that's how we're going to go ahead and set that up. Let's go ahead and take a look at our example really quick. For our example, we'll go ahead and start with nums equal to 3, 6, 1, 0. And then we're going to go ahead and start out max as 0. And index equal to -1. Then from here, we can go and say I equal to 0. Our nums of I is equal to 3. And of course, our max is equal to 0. Now, obviously, nums of I is greater than max. So we'll go ahead and set max equal to 3 and index equal to 0. And then next, we'll go ahead and say I equal 1. Nums of I will be equal to 6. And now max is equal to 3. So once again, nums of I is greater than max. Let's go ahead and set max equal to 6. And go ahead and set index equal to 1. For I equal to 2, our nums of I will equal to 1. And our max is now equal to 6. Max is now greater than nums of I, so we just continue. For I equal to 3, nums of I is equal to 0. And our max is equal to 6. So once again, we're going to go ahead and continue because nums of I is less than max. So this is end of loop 1 or end of step 1. And we'll go ahead and start the loop over again. So now our max is equal to 6 and our index is equal to 1. Now we're going to go ahead and say I equal to 0 again. And now we're going to say max is equal to 6. And then our nums of I times 2 is equal to 6. So in this case, max is greater than or equal to 6, which is that nums of I times 2. So we continue. For I equal 1, the index is equal to I. So we're going to go and skip. For I equal to 2, our max is equal to 6. And our nums of I times 2 is equal to 2. So obviously max is greater than or equal to 2. So we continue. For I equal to 3, our max is equal to 6. And our nums of I times 2 is equal to 0. So obviously 6 is greater than or equal to 0. So we continue. This is the end of step 2. Since we made it all the way through the loop, we'll go ahead and return the index, which is equal to 1. So that is how we can go ahead and fix this up. Let's hop over to LeetCode and solve this for you guys. All right, over here on LeetCode, we're going to go ahead and inside here, we're going to say int max is equal to 0. We're going to make an int index equal to -1. And then we're going to go ahead and do the first step. So for int I is equal to 0, I is less than nums.length, and I plus plus. Inside here, we'll say if nums of I is greater than max, we want to go ahead and set max equal to nums of I. We'll set index equal to I. Then we'll go ahead and start the second step for int I equal to 0. I is less than nums.length and I plus plus. Then we're going to check if our nums of I times 2 is greater than max and our I is not equal to index. We will return -1. Now outside the last for loop, we'll go ahead and return index. Hopefully I didn't typo again like I just did previously. And there we have it. We get a 0 millisecond runtime, which also beats 83% of memory complexity, so it works pretty well. If you did find some value in this video, of course, please like, comment, and subscribe. It always helps out. As always, my name is Ethan Encoder. Hope you have a great day, everybody, and I'll see you in the next video.